I'm Anil Kumar. In this list of videos, we are learning about rational functions. Here we will discuss discontinuity and restrictions of rational function. That's the first thing. And then we'll discuss conditions for whole and vertical asymptotes. So these are two related topics which we are going to discuss now. Discontinuity and restrictions of rational functions. Now any rational function, is a ratio of some polynomial in the numerator, let's call it n of x, divided by another polynomial in the denominator. And since we cannot divide by 0, d of x is not equal to 0 leads to restrictions. Do you see that? That is restrictions. So a polynomial divided by another polynomial, that is ratio of two polynomials, is a rational function. However, the denominator of a polynomial cannot be 0. So equating denominator to 0, we can find the restrictions, right? Now, whenever we have these restrictions are restrictions on domain of the functions, right? Restrictions means restrictions on domain of function. Do you understand that? Domain of function. Now let me give some example to elaborate. Let's say we have a function p of x which is equal to 1 over, a very simple example here, x plus 1. Now of course denominator cannot be 0, so we say x plus 1 is not equal to 0, or we can say x is not equal to minus 1. Now this minus 1 is a restriction on domain, correct? So for this function we'll say domain d of x is x belongs to real numbers where x is not equal to minus 1. Do you understand this part? So that is how we find restrictions. Correct? Now let me give you another example here. Let's say m of x is equal to 2x minus 1 times x plus 1 divided by, let us say, x plus 1. Let me multiply this by x plus 2 also. Now in this particular case, we have two restrictions, right? So the restrictions are that x plus 1 is not equal to 0, that is x is not equal to minus 1. The other restriction is x plus 2 is not equal to 0, that is x is not equal to minus 2. You got it, right? So we can say here that x is not equal to minus 1 and minus 2. Here let me write x is not equal to minus 1. Is it okay? So these are the restrictions, and always when we write a rational function, we should think about these restrictions. If they are not written, it's better to write. Okay, so you're clear how to find restrictions, and these restrictions really mean that if I have to write domain of this function, then we will say x belongs to real numbers where x is not equal to minus 1 and minus 2. Perfect. So restrictions are restrictions on domain of function. Perfect. Now let's look into the second point, which is conditions of wholes and vertical asymptotes. Now these two examples are very important. You see in the second example, we have a common factor which cancels out. So this common factor leads to whole. So out of these two restrictions, x equal to, the common factor cancels for x equals to minus 1 is a whole. Is it okay? The other one, which did not cancel, leads to vertical asymptote, right? So the factor in denominator which does not cancel with numerator factor leads to vertical asymptote. Is that clear? So the vertical asymptote is the other restriction, which is x equals to minus 2. So we have a vertical asymptote here, which is x equals to minus 2. So this is a very important condition which is to be understood, right? We'll explore this further. So whole is a common factor which cancels. In this case, as you can see, what do we have? There is no common factor between numerator and denominator. So here we have a vertical asymptote, and that is at x equals to minus 1. Do you see that? So that is how you figure out wholes and vertical asymptotes. So we'll take some examples to elaborate on it. You can follow the link which I have on this. You can also search for Anil Kumar rational functions playlist to get more examples to discuss the same thing. I'm Anil Kumar, and I hope that helps. Thank you and all the best.